Hi, welcome to an Arduino tutorial from Robojax. I am Ahmad Shamshiri from Canada. In this tutorial, I'm going to show you how we can build an LED 7-segment display clock using the DS3231 module with Arduino. You can get the code for this by clicking the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. For a while, I've been looking to build an LED clock using Arduino. I could not find any code available that makes it easy for a 4-digit 7-segment display, so I had to write my own library, and I spent a lot of time working on it. The issue was when the Arduino is turned off, the clock would be resetted. So I had to use a clock module. There is a real-time clock module that I've created a video for it. It's DS3231, which has a battery. When you turn off the Arduino, still the clock is running and time is keeping. So I'm using that module, which has only 4 wires, 2 for the power and 2 for the I2C clock and the data. I have a separate video for that. You can watch it separately, and it can display the code on the screen, and you can use alarm and do many other things. So I'm using that one, passing the value from that on the display using Arduino. We have 4-digit, and also we have colon, or the 2 dot that is between minute and hour. The colon that divides hour and minute is blinking once a second. It is turning off for half a second and turn on for another half a second. And still you might see some issue with that. I'm working on it. So to select the 7-segment display, you need to get either common cathode or common anode. If you search for Amazon, eBay, or AliExpress, you will find the majority of the LED display or common anode. That is fine. The library that I have written will accept the type. Either you select common anode or common cathode, and it will work fine. And final point that I have to mention is that this can be used with Arduino Uno or Arduino Mega. If you are using Arduino Uno, all the digital pins from 2 to 13 will be used, because we need 7 pins for a 7-segment display, and then we need 4 pins for the common of 4 digits, and also we need 1 pin for the colon to blink. So I'm using pin 13. If you're using an Arduino with lots of pins, there will be no issue, and you can pick different pins on Arduino. You need to download the library for the DS3231 clock, and then you need to download the Robojax 7-segment display clock. Both of these are needed. In 7-segment display, for each digit, we have 7 LEDs. In order to divide the voltage and limit the current, we need to use resistor for each LED, which means we need 7. In many circuits and publications that I've seen online, people incorrectly using for 1 digit, they are using 1 resistor, and the problem for that is, and if you use 1 resistor, because for example, if you want to display 1, only 2 segments will be turned on, and it will use very less current. And if you try to display 0, all of the segments except 1 will be off, and there will be so much current, and light will be dim. In order to have consistent intensity of light, we need to have 7 resistors connected and series with the LED, either as common anode or common cathode. Now let me explain the wiring and common cathode and common anode quickly. I have a separate video explaining the 7-segment display. I'm going to quickly show you how they work so you can use it. This is the 7-segment display that we are going to use. It has a colon here at the middle, and these decimal points are not used and they are not connected, and I don't know why they left it like this. It would have looked nice if we did not have these decimal points. And so for all of the digit segments, A, B, C, D, E, F, and G, they're all connected to single pin. So 1 pin is A, B, C for all. So we have 7 pins plus 4 pins for each common. That will be 11, plus the decimal point will be 12. That's why we are using from pin 2 to 13. And here is the wiring diagram of this from circuittoday.com. All anodes are connected. This is common for 1st digit, 2nd, 3rd, and 4th digit. And on this side, all A are connected together, the segment A, the segment B, C, and D, and so these are A, B, C, D. And here, this is from circuittoday.com. As you can see here, this is one digit, this is a second digit, third, and fourth digits. For each digit, they put only one resistor. And that causes the display to have inconsistent intensity of light. We should have resistor for each LED at this point, not there. Here, for each segment, this portion is A, this is B, then we have C, D, E, F, and G. And you can turn different segments to display different numbers. And here briefly, if you want to know, to turn on 0, we have to turn on everything except G. So this will be read as 0. For 1, we have to turn on B and C. And for 2, we have to turn on A, B, G, E, D, and so forth up to 9, as you can see here. The LED display that we are using is common anode, meaning each diode, the anodes are all connected together, so this can be turned on with positive. But in order to turn each segment on, you have to connect this or make this 0 or negative, so the current can flow and it will be turned on. There is also common cathode. In that case, all the cathodes, as you can see, the direction is now the other way. All the cathodes are connected together, and you have to send positive on each segment to turn it on. So this will be connected for once for all, and then each segment can be connected to positives to be turned on. The common anode, as you can see, they are all common. You cannot put one resistor for all. You have to put resistors on the cathode for each. And if you have common cathode, then you can put the resistors on this side. From the point that it comes before connected to the 7-segment display, put a resistor. And here are the pins for the display. If you look at it from the top, we have 6 pins on this side and we have 6 pins on this side. Each segment is A, B, C, D, E, F, and G, and this is called column. These decimal points are not working. LED. So for each element we have A, you can see here B, C, D, E, F, and G. And then for each digit we have one common pin, which is the anode. For digit 1, that is D1, and then D2, D3, D4. And then this DP is decimal point. And here let me explain the wiring, how I've put it on breadboard so it makes it easy. I did not connect the resistors directly to these pins, rather I put a wire and then connected it so it is clean and easily understood. And because we have 6 wires here, 6 pins on this side, 6 pins on that side, I've connected 6 wires here and 6 wires here. Let me remove this so you can see that this has been connected directly there. And here I also put the diagram here so you can understand it easily. First, for the 4 digits I put blue wires, and here for digit 1 at a lower section, this is the first pin. As you can see here, the first pin, it has been connected at this point. That is digital 1, this digit 1, and digit 2 is here, the second pin, and digit 3 is here, and digit 4 is the last one, accordingly as it's shown here. So I've connected them here. These will be connected to pin 8, 9, 10, and 11 accordingly. I've connected wires for each segment. For example, segment A, B, F, as you can see it here. So this is A, the second pin, first. This is the first and then second. I put here in a yellow to this point, and for each one I put a yellow wire, and then the last one is the DP decimal point, the third from the left, so first, second, third, and I put the red one, and that is in here, which I've connected to this point. in here. So you understood all of them, and I put them accordingly. So this is pin 1, 2, 3, 4, 5, 6, exactly the same way, so we can follow here, except with the red that I moved it the other way. Now for each of these yellow, which are the segment, I connected a 470 ohm resistor. This is for, on this side you can see we have 3, and on this side we have 4. For each I've connected one resistor, so 3 here and 4 here. Those are for the 7 segments, each separately with one resistor. Now let me connect the wires. So from this point, 2, 3, 4, 5, 6, 7, and 8, these are 7 pins for the 7 segment. This is for A, B, C, D, E, F, and G. 8 is G. Now I've connected them like this. I will explain 1 or 2 so you understand. Black one is A. This black is A, the first one, and it has been connected to this point, which is connected to this resistor, and which is connected to the second pin, the yellow. So you can see here that it is connected to A, and the same way for all of them. Now for the common digits here, for digit 1, this will be connected here to pin 9. Pin 9 is, as you can see, is orange. So the orange is going to pin 9, the first one. That is digit 1. This blue, I've connected it in here. Digit 2 here, this goes to pin 10 because this was 9 and I'm going to 10 accordingly. So pin 10 is here, red, as you can see, and I'm connecting pin 10 for the first blue here. That is going to 10, and it is connected. This one I have to connect it such that it doesn't touch these resistors wires. Let me zoom in. So I'm inserting it in here, making sure that the resistor wire doesn't go beneath it. And decimal point is the one that is connected here with the red. This is the decimal point which has been connected to this point, and I have a resistor connected here via white wire. It has been connected to pin 13. For the clock module, we have ground. This red is ground, have been connected to the ground. The second pin VCC, this has been connected to 3.3 volts. And then we have SDA and SCL. SDA have been connected to A4, and SCL, the clock, is connected to A5. This is for the module. Make sure that you have battery so it can hold the time for you. The 7th segment, this goes to A, B, C, D, E, F, and G from 2 to 8. And then 9, 10, 11, and 12, it goes to digit 1, digit 2, digit 3, and digit 4. And pin 13 is used for the decimal point for the column that blinks. Now let me explain the code. You need to download 2 libraries. One is the DS3231, which will initialize the clock module so you can get the data from the clock, and the other one is Robojax 7-segment clock. You need to download these 2. The link will be provided as a zip file. Once you download it, save it in your computer in a location that you know, and after that click on Sketch, include library, add .zip library, and then point it to where you have saved it for. Click on the file and then click open, and do this also for the other one. So for both, once you're done, click open and then close, and then close this. For example, now I have 2 instances. Close all of them and then reopen it. Once you reopened, then click File, Examples, and scroll down with R after this line to see Robojax 7-segment clock, and there is one example at the moment. Click Robojax clock and this will open. Now let me explain it. The first line wire.h is part of Arduino IDE. You don't need to download it, is included. This line is from the library for DS3231, and from this class we are creating an instance and we call it clock, and then RTC date time also initialized, which is included with this. We call it DT. So these two are needed. And then include Robojax 7-segment clock.h. This is part of the library that you just download. From this portion to this is all for the 7-segment clock. We first create an array called digits. These two square bracket means it's array of type integer, and we define it as constant, so it cannot change. We put the pins for 4 digits for the common pins, 9, 10, 11, 12, and then these are for the segment of the display pins. We have 7 of them from pin 2 to 8, and then a pin for the column, which is pin 13 on Arduino Uno. I've left this open so you can choose any different pin if you have Arduino Mega or something like that. And then type 1, if you are using common anode, type here 1, and if it is common cathode, make it 2. Then from this class we create an instance, we call it CLK clock, because there was clock already reserved, so I use CLK. And then we pass 1, 2, 3, and 4, all of this with a comma: display pins, digits, column pin, and type. All of these will be passed to the library so it can be used. Inside the setup, we initialize serial monitor, even though initially you don't need it, but I just included it in case you want to debug or print something. And then this is printing the text on the screen, and clock.begin initializes a clock. CLK.begin, this is initializing the 7-segment display, and these two lines are also printing the text for us. And this line I've commented this out. If you need to update the clock module, uncomment this, meaning remove these two /, so this line will run, but you need to run it only once. Once this runs, it takes the date and time from your computer and uploads it to the module, so your module will have the current time that is on your computer. And if you want to play and have different times, you can do that as well. And now inside the loop we run clock.get date time. This will get date and time for us, and it is called DT here. And if you use serial monitor, DT year, it will print the year from this object. .month will get the month, .day, hour, and so forth. But for our purpose, we are using hour and minute, and we use CLK.display time, and we pass hour and then comma and minute, because we just need hour and minute on our clock display. And inside the loop we have 1 millisecond delay, and the loop continuously doing the same thing. And now let me power it up. (21:25), that's the time now, 9:25. Now there is an issue here with the blink. This goes half a second on and half a second off, but there is something with the code that it needs a little attention, that after 30 seconds this blink intensifies and increases in terms of time. I've inserted LED, and this is the top, that's the bottom, and at the bottom we have 4 resistors that have been connected at these points, as you can see, and 3 at the top. And I've bent all the pins and inserted the resistors. The resistance will bend and directly will be soldered to the pin of the LED. I'm going to solder it and then cut the wires and show you again. Now the pins have been cut. I'm going to connect. If you look here, I'm doing, the last one is not connected, these two. This is D2, D3 and D4, the last one. And on this side I have D1 and then decimal point at these points. So the wire will be connected. Male to female pin header, I'm going to solder it. And as you can see, this is the lower section and that's the upper. Either I can connect it here so the wires can be inserted from this side and bent, we can see it, or you can connect the wire from that side so you can see it easily. I'm going to do it on this side. The pin header is now soldered, and here I've soldered all the wires that were needed for this side and on this side. I'll provide you the photos so you can follow it. I've added this resistor for the decimal point and connected the decimal point from pin 13 to the resistor which goes to this pin. Here I've connected exactly the same way the wires have been connected from pin 2 to 13 have been connected here from pin 2, 3, 4, 5, 6 up to 13. (1507). I turn the light off so you can see it properly.